Today we're going to be doing the rules on exponents. Just a brief overview, just to remind you of the rules. When you have exponents being raised to an exponent power, you multiply the exponents. When you have exponents being with like bases being multiplied, you add the exponents. And when you have bases being divided with the same base, like base, you would subtract the exponents. Multiplying exponential problems with like bases. If there is a coefficient, you multiply the coefficient just like you would multiply any other two numbers. So 5 times 3 is 15. I'm going to rewrite it to where my like bases are side by side. So x to the first and x to the fourth. Y to the seventh and y to the eighth. The rule for multiplying like bases is you add the exponents. So the exponent on the one that's not written is a 1, because it's understood to have the first exponent. We raise the first power if it is a 1, or not written. And so the 15 gets rewritten again. X to the 1 plus 4, 5 is the exponent. Y, 7 plus 8, 15. So my answer is 15x to the 5th, y to the 15th. Dividing exponential problems with like bases. When you are dividing, you will reduce the coefficients and subtract the exponents, but leaving the variable on the side, either numerator or denominator, that has the highest power. And so we're going to first look at the coefficients. What number divides into 8 and 24 evenly? Well, they're both divisible by 8. So 8 divided by 8 is 1. 24 divided by 8 is 3. Now we're going to choose a side that has a larger exponent for the x's, and that would be in the denominator. We're going to choose a side that has a larger exponent for the y's. That will be the numerator. So let's rewrite it, and we're going to subtract and leave the power in the side that is the largest. So let me rewrite this. We have 1, and the y is what we circled in the top. And so for the exponent, we're going to do 10 minus our exponent for the bottom, which is a 1, because it's not written, so it's understood to be 1. In the denominator, we have 3 x to the 5th, because that's what's there, minus the exponent from the numerator, which was a 4. So let's write our final answer. We do not need the 1 in front of the y, so we have y to the 9th power in the numerator. In the denominator, we have the 3, and x to the 5 minus 4, which is 1, and we do not have to write the 1 that's in the exponent. That's your answer. Raising a power to a power. So we have something that we're raising to a power. And if you look here, what this means, if I was to rewrite this, it means I have 3x cubed y times itself 4 times. X cubed y. 3x cubed y. And one more, and I'm going to write it on the side. 3x cubed y. So we're multiplying it times itself 3 times. And because we like to shortcut things, we want to find out a way of shortcutting this process. Well, repeated addition is multiplication. And so instead of writing it out that many times, we shortcut it and distribute the power to each one. And what often gets forgotten is your poor little coefficient. He gets that power as well. So 3 to that 4th power. X cubed is being raised to that 4th power. And y to the 1st is being raised to that 4th power. So when we have these, we're going to multiply the exponents. And we are going to simplify our coefficient. So 3 to the 4th power is 81. X cubed to the 4th power is 12. That means I have 4 sets of x cubed, which means I have 12 x's being multiplied. Y to the 1st raised to the 4th power is y to the 4th. That's my final answer. So the last one we're going to go over today that's going to be in the escape room is raising to the 1st or 0 power. And so if you're raising something to the 0 power, let's say you're raising 7 to the 0 power, that answer is 1. No matter what I put inside here, if I'm raising it to the 0 power, it is always 1. I could put the craziest equation in that spot, or even something that you may never have seen, and I raise it to the 0 power, that answer is 1. Now, let's say, instead of to the 0 power, I am raising it to the 1st power. It is itself. No matter what's in there before, if I raise it to the 1st power, it stays itself.